Okay, this is Chapter 1, Section 2, Estimation and Interpretation. We're going to interpret graphs and choose appropriate place values when estimating. Getting a rough idea, roughly calculate, numerically, you're rounding. And rounding is based on the decimal system or something called the place value system. And to help, at the bottom of this page here is the place value chart. So if you're not familiar with that term or these terms on the chart, you might want to take a picture of it and keep it handy for rounding instructions for every problem. Alex is very specific for wanting things rounded to the place value they want. Ones is the same thing as dollar or whole number. To the nearest cent is the same thing as 2 decimal places, right? Cents, dollars and cents. As hundredths is another term for that. On the left is all the whole number parts of a number, and these are the fractional parts of the number. So I didn't want to get too bogged down in that. We're just going to estimate by rounding to a place value that either they say or we're going to pick. So let's look at the first one. Example 1, it says a dollar amount rounded to to 100. Where's 100? That's 100. So when we're rounding, if you remember, it's here's a little saying that might help. If you don't remember, 5 and above, give it a shove. 4 and below, let it go. Well, what are they talking about? Well, this answer is either going to be 1600 or 1700. That 6 either stays the same or it gets rounded up because of the next number, which is an 8. So since the 8's above a 5, we're going to round it up. So the nearest 100 would be 1700. Okay. If you're looking for the dollar, the nearest whole number or dollar is that 9. So that 9 is going to be rolled up to a 10, which is going to affect the number above it. So it's going to be 1690, or it's going to be 1689, and it depends on this decimal place here, which is a 2. So it's 4 and below, we're going to let it go. So rounded to the nearest dollar. Look at all the things you're doing when you're rounding things to the nearest dollar. You probably already knew how to do that. So we're just getting all the terminology down. Rounding things to the nearest cent. When you're calculating things out and you're talking about money, you're rounding to the nearest cent. So that's where the 7 is here. So we're either keeping the 7 or rolling it up to an 8. So it's going to be 1689.2. And then we're looking at the 5. So 5 and above, give it a shove. So it's 28 cents. And then to the nearest thousandths is this place here. So 16,892,75, and it's probably not going to be dollars, right? Thousandths place. We're keeping that 5 because of the 3. Okay. Number 2, we're going to estimate the sale price of a chair that costs $178.99. So I don't know, 200, 175, 180. Sorry about my phone. That's a weather alert. I can't figure out how to turn them off. Let's see. If I estimate it to be 100 or 200, 40% off, let's see, half would be 100. So a little less than 100 off would make it a little over 100. Did that make sense? If it was 50% off, I mean, I'm trying not to do math. I'm trying to estimate, right? If it would be $100 off if it was 50% off. So it's going to be less than 100 off. So it'd be, I don't know, like 120. I have no idea. I'm just estimating. Okay. So, but if I started out with more like that's 175, um, and you're only taking 40% off, I don't know that maybe that takes off the 75. So we're talking maybe around $100. Um, so these are my two guesses. Um, it actually comes out to be 107 and some change mathematically. So that's not too bad, right? That's close enough. About $100. Example number 3. It says total cost of the following meal at a takeout place. I mean, the burgers are about $4. The fries are about $2. The shakes, I don't know, about $1. If I went up on some other ones, I go down on some other ones. So my meal is about $7. If you do actually crunch out the math, it comes out to 707. So that's pretty good. Um, Example 4. Jamal earned $8.75 an hour. Estimate how much he would earn per year. Assume that he worked 40 hours a week, 50 weeks a year. I would have a hard time estimating that. I might want to just do the math on that. Maybe you could, I don't know, round it up to $9. You're doing 40 hours a week, 50 weeks a year. Get my calculator out. I don't know, 18. So, well, since I used a 9 instead of 875, it's less than 18,000 a year. That's about an estimate. So it's important to know your place values is all I'm trying to say. So oops, let's look at the charts. This is a bar chart of a type where it, see how the x axis, that's the horizontal axis, um, has words. It says language. Should read the title, most common native languages spoken. Um, Number of native speakers on the x or vertical axis. Language type here. So clearly there it says the most important piece of information from this graph. I would say that the most common native language um, is Chinese. Let's see. And we're talking, read the scale here. Native speakers, millions. So 1,200 millions of native speakers of Chinese. So clearly outnumber everybody else, maybe even combined. Um, any other information? Spanish is second. Um, English is third. Um, English is only about, is less than 40 million, 400 million. So let me write that down. English less than 400 million. Chinese was 1,200 million. I'm not going to take the time to put all those zeros after that, but clearly more Chinese. Even Spanish was 400 on the nose. So this graphically represents a lot of information right there. Pie charts. Um, let's see. Pie chart. This is called, let's see, fatal occupational injuries. We have contact with objects and equipment, assaults and violent acts, falls, transportation, harmful substances, fire and explosions. A lot of statistics and data have to do with insurance liabilities and criminality and sociology. There's a lot of, it's not all happy stuff. So let's see. What does the question say? What injury is most often fatal in occupational injuries studied? Most fatal. So it looks like more people have a problem getting to work or driving a truck. Apparently, something to involve transportation seems to be the issue. That's interesting. Um, Which set of causes is more likely to be fatal? One or two? Let's see. One says fire and explosions. That's 3. Exposure to harmful subjects. That's 7. Contact with objects and equipment. Don't get your hand stuck in the doohickey. That's 10. 26 about percent. Falls. Falls are 14. Assault and violent acts are 17. 31%. Oh, falls and violent acts are more likely. Last one is Americans in poverty from 1900 to 2015. This is a time series or line graph. To read it, you want to find, let's see, find the approximate number of the Americans living in poverty in 2015. So these lines here and these lines here were drawn in to demonstrate that. So the time series line itself has 1, 2, 3, 4, 5, 6 points on it, and they're just connected to each other. And then to read what this point is right here, this is 2015, and then you follow it back and you have to estimate. It looks a little more, maybe 43 and a half are living in poverty, 43.5, and I'm assuming that I chopped off, I apologize, the very important thing that says how many that is that 43%? Is it 43 million? Sorry about that. It's 43.5 going across. I apologize. Let's see. Find the average rate at which the number of Americans living in poverty changed between 1995 and 200. 1995 and 2000 is 5 years. 95 and 2000, it looks like it declined. So what is that? That's about, I don't know, 37 if you go across for 95, and 2000, I don't know, 32. It declined about 5. Oh, I wrote million on my notes, so this must be million. And it doesn't describe what the poverty line is and what they're using. That's the limitation of this graph. And they went down 5 million per in 5 years. So that is down approximately a million per year in that time period. And let's see, 2000 to 2010, 2000 to 2010, 2000 was 32, and apparently it's going up, and this is what, about 47. So we're estimating where these things are as we go across. 15 million, but this was over a 10-year period. So I don't know, about 1.5 million up per year. Okay, so you can read a lot of information from graphs, and I think that's it for this section.